find the limit if it exists. And here we have the limit as x approaches infinity of the square root of x squared plus 1 minus x. Now, there's an interesting thing we're going to do here. This isn't a rational function, so it ends up being a little bit difficult to work with, but we can make it a rational function. We have seen situations before where we had a square root minus something. And what we're going to do is we're going to multiply by the conjugate, or the square root plus that thing, in the numerator and denominator. So we've got the limit as x approaches infinity. I'm going to write this as the square root of x squared plus 1 minus x, and I'm going to put that all over 1, which doesn't change its value. And now I'm going to multiply the top and bottom by that conjugate, the square root of x squared plus 1 plus x. And this is definitely not 0, right? If we multiplied the top and bottom by 0, that would be an issue. But as x approaches infinity, none of these are going to be 0, so we're good to go. Now, when we do this multiplication, remember we get a difference of squares on the top. When we've got a minus b times a plus b, that's a squared minus b squared. When we square that first term, it just gets rid of the square root. So that's going to be x squared plus 1. And then minus, when we square x, that's going to be another x squared. And then this is all going to be over 1 times anything is itself. So this is going to be the square root of x squared plus 1, and then plus x in the bottom. Now those x squareds are going to cancel out in the numerator because one's positive and one's negative. So we end up with the limit as x approaches infinity of 1 over the square root of x squared plus 1, and then plus x. And then we can use the trick that we used before, where we want to divide the top and bottom by the largest power of x in the denominator. That's just going to be x, because also, even though we have an x squared in here, the square root of x squared is just x. So we're going to divide the top and bottom of this by x. So it's going to give us 1 over x in the top. And then in the square root, dividing by x is the same as dividing by x squared under that square root. And we don't have any problems with negatives because x is approaching positive infinity here. So when we divide by x squared in there, that's going to give us 1 plus 1 over x squared. And then plus, when we take x and divide it by x, that gives us 1. All right. So now we're at the point where we can take this limit and we can bring it into the fraction in the numerator and denominator. We can split up these terms as separate limits, and then we can pull that limit inside the radical. We can use all those limit laws, and this gives us the limit as x approaches infinity of 1 over x, all over the square root of the limit as x approaches infinity of 1, plus the limit as x approaches infinity of 1 over x squared. And then outside of the radical, again, we have the limit as x approaches infinity of 1. And when we evaluate these limits, we end up with 0 over the square root of 1 plus 0, and then plus 1. That's going to end up being 0 over 2, which is equal to 0. So that whole limit that we had in the beginning is equal to 0. If this algebra was a little bit too much, or you don't think you could do this trick, you don't think you could remember this trick, you can always make a table of values with a calculator. This option is always better if you can do it, because if our limit is something like 6/13, you probably aren't going to recognize that as the limit when you've got a table of a bunch of decimals, because that is an ugly decimal. So these algebraic methods are always a better choice when we can use them. But if not, if we're struggling for some reason, we can always try a table of values. And in some circumstances, it is quite illuminating.